Life is too short to work at a crappy company. That's why Software Engineering Daily is proud to be sponsored by Hired.com, the job marketplace for software engineers. If you accept a job through Hired, they will give you a $2,000 bonus. But as an extra bonus to our listeners, you can get an additional $2,000. That's $4,000 total if you sign up by going to softwareengineeringdaily.com and using the link on the right side of the page to sign up. Hired.com will set you up with 5 great companies for interviews. These are companies like Stripe, Facebook, Uber, companies you would actually want to work for, where you can go and learn the cutting edge of software engineering. Go to softwareengineeringdaily.com, click on the banner on the right, and try out Hired.com. David Drummond and Austin Ouyang are program directors of the Insight Data Engineering Fellows Program. David and Austin, welcome to Software Engineering Daily.
Hi. Thank you for having us.
So what is a data engineer?
Well, that is a relatively new term that hasn't necessarily found like a single definition, but there are a lot of definitions that go around. So I guess we can answer what a data engineer is, but we can also say a little bit about what a data engineer isn't, and that might also be helpful. So the most, at least in my opinion, blunt definition is a data engineer is someone who is aiding a data scientist to actually have an easier time working with the data. And there's a common expression, which is, a data scientist spends 80% of their time, wrangling data, and the rest of the time complaining about it. But if there's a good team of data engineers there, then that's not the case. The data engineer can help build the pipelines that actually process some of the so-called ETL, the extract, transform, and load. And also do some more sophisticated, analytics and feature engineering to kind of take out the quote unquote grunt work and allow the data scientist to really focus on the business logic and the more interesting analysis.
Would you say that like a data engineer is programming the applications for a data scientist to operate with, much like a software engineer is programming the applications for the end user to deal with?
Yeah, I think that's fair. I guess one little difference I would say is that sometimes a data engineer is working directly with an end user. So it's a little bit between those. And in fact, a data engineer, you could say, is a specialized software engineer who's specifically working on data. And so sometimes that end user is, your customers, and sometimes that end user is a internal customer, such as a analyst or a data scientist.
And what is the workflow of an average data engineer? What are the tools that a data engineer is working with, and the types of problems that a data engineer is tackling day to day?
Yeah, I think one of the important things for a data engineer to keep track of is actually as they're working in between like the data and also the data scientist, or the end user, is they need to be thinking about scalability and fault tolerance. So even if they're a data engineer at a smaller company where they may just be working with, say, like a MySQL database, they should be very forward thinking in terms of if this company is to continue to keep growing, like how they would actually want to scale out their infrastructure and also make it fairly seamless for both the end users, whether it be data scientists or like an end consumer.
And so at some companies, DevOps or operations or whatever the company likes to call their sort of next generation sysadmin type of roles, these people are in charge of managing some of the back end data stack. Like I've worked at a couple places where the people that were quote unquote DevOps were also in charge of doing some Hadoop configuration and this type of stuff. Does a data engineer's work overlap with what has been maybe in the past 5 years or so referred to as DevOps?
So I suppose there is, of course, some overlap, but this kind of goes back to that point which I was saying earlier, which is there's certain things that a data engineer isn't. And in the best case scenarios, I would say doing nothing but DevOps or doing a significant amount of the DevOps is something that would not hopefully fall into the responsibilities of the data engineer. Of course, at smaller companies, maybe that's the best person to take care of some of that stuff. But I think in larger companies, there is a little bit more of a division of labor, and it would be more, writing the actual engineering, like writing the actual software, as opposed to configuring and doing the DevOps. But there's certainly it's certainly the case that a data engineer should know their way around some of the configurations and the actual DevOps and be comfortable tweaking those things to optimize.
How has data engineering changed from the previous methods of, like ETL and data warehousing, these terms that have been around for a while? What is new about data engineering?
Yeah, so I think as Austin was describing before, the main difference is that we now have these specialized systems like Hadoop and Sparc, and new ones that are emerging all the time, and these NoSQL databases that are more and more replacing the old relational data warehouses. And these tools are becoming more specialized, and they are distributed, and because of advances in the price and capabilities of memory and SSDs, there is becoming a new kind of specialized approach to actually working with these tools. And you need someone who's going to focus specifically on how to get these distributed systems to work, how to make sure that when a node goes down, as if you have 100 nodes, it's inevitable that one of them is eventually going to go down. And so when that does happen, you need someone who's very familiar with those. And so what used to be done, with a traditional ETL job that could be kind of managed and ran in a relatively simple way, it's becoming a much more complicated process. And so I think the modern data engineer needs to understand these intricacies of a distributed system, in addition to how to actually run these ETL jobs.
So we've got the increase in distributed systems importance, and we've also got this shift towards a wider variety of technologies that we're using. I think about streaming frameworks, and over the past decade, many companies have built out their big data stacks with mostly a focus on Hadoop Mapreduce and the rest of the Hadoop stack. But Hadoop Mapreduce has kind of been getting replaced by stream processing frameworks. What is the motivation for that? What are the problems with Hadoop Mapreduce?
Yeah, I think I would one of the pain points, I guess, in Hadoop Mapreduce is that it works great on a lot of data, but one of the problems is that a lot of each process of when it's doing the mapping and the reducing, it's all working with the hard drive itself. So every time it does a process, it must read from it, and then after it does the processing, also write it back in. This iteration will take a long time, especially if you have specific algorithms that need to iterate on a very large data set over and over again, maybe thousands of times. And it could take maybe even weeks to compute. So now people are trying to move more into one is more into the memory computing, or even just the stream style of computing. And with memory getting cheaper as well, it seems like that's kind of where the industry, or a lot of people are trying to move towards, these types of frameworks that can quickly do iterations on very large data sets. And this can include Sparc and Flink.
And so if I want to add streaming functionality into my straight up batch processing framework, just Hadoop Mapreduce, is this the type of thing that I will need to be doing as a data engineer? Is this my responsibility to add the streaming functionality to a all batch framework?
Yeah, I think it's part of the data engineer's responsibility to also evaluate these tools. So it is always very scary to just say, let's go ahead and migrate completely over to a specific technology. So I think it was definitely part of the data engineer's role to try out various tools, kind of like beta test them to see how well they can potentially work in production. And then by benchmarking them against other streaming technologies and decide if it's worth the manpower time to actually get it up and running to move that through. And depending on the company size, I would say is data engineer may be the one who needs to do all the DevOps to actually get that up and running. But essentially, I would think that it'd be better to offsource that to a DevOps team as well to take care of security.
Yeah, and in terms of making sure that there's an actual use case and an appropriate use case for streaming specifically, I think that's something that the data engineer would have to work very closely with the data scientists to figure out. Does this algorithm actually need streaming? Like, is there actually a need to have something up and running and have it like updated every 5 seconds or every 50 milliseconds or whatever that actual latency demands are? I think it's very important to figure those out. And it's also very important to understand like the algorithm that's going to be used, whether it's some rather simple effectively just division, or if it's some really complex deep learning machine learning technique. Whether or not that's actually possible in a streaming framework is a non-trivial thing, and I think that's why a data scientist would have to work closely with the data engineer to actually implement these things and move them to production quality. Because what works with a small data set doesn't necessarily scale.
And one of the approaches that I've seen with these batch and streaming developments is the Lambda architecture. What are your guys' thoughts on the Lambda architecture? And do you teach this as a way to deal with different latency requirements across a big data stack?
Yeah, so we definitely teach that in the course, in like the fellowship program. We don't try to push all the fellows to move towards that, but it's something that we bring up in terms of if you do need like less like sub-second latency to understand what the Lambda architecture is, and basically not kind of take it for granted too. We explain to them just the complexities that arise from basically trying to combine the batch processing and the streaming process, and they kind of get the idea of that it is not a trivial process as well.
Yeah, could you define the Lambda architecture and talk about what problem it solves?
Yeah, sure. So essentially, the problem in the past was that you have some batch job that runs in the background, and it may maybe like take several hours for it to compute. So as I get some streaming data that comes in, that maybe like you get maybe like hundreds or maybe thousands of events that happen every single second, I may want to know what is happening exactly right now, right? So in that case, I wouldn't have the most up-to-date information if I just run the simple batch job. So it's more of using the streaming process to kind of enhance the batch processing, basically to provide, do the calculations for the most recent data that has just come in, and you merge the batch and the real-time together so that you can get the clearest picture of what is going on right now. But with this, sometimes the real-time process, it could be doing some sort of approximation. And you may also be accumulating errors along the way too. So with this Lambda architecture, since the batch job always runs over all of the data, then it will always recorrect itself every time it recomputes again. So it's the fact that the batch job has this huge latency to compute, and trying to combine that with the streaming layer can be quite challenging.
Yeah, and to elaborate, I think it's worth focusing because I know a lot of people who discuss the Lambda architecture just say it's mixing the streaming and the batch, and that's all there is to it. But this aspect that Austin was speaking to of actually recalculating on your entire data set, that has many advantages. So that helps you with problems that require you to look at all your data sets. So if you're trying to find the number of unique users, and it's possible that some users have multiple logins or multiple email addresses, that's really something that requires you to look at your entire data set as a whole. And so the Lambda architecture fits very well for that. The other thing is if you introduce like bugs into your code, which, as you know, any software engineer knows, this is pretty much inevitable. The Lambda architecture automatically corrects for this by, recalculating. Like if there was a bug introduced, you just fix the bug and then you can recalculate on the entire data set. But so the other aspect of this is this so-called human fault tolerance. It doesn't just account for if nodes, make a mistake, but if software engineers make a mistake, or if business logic changes, you can easily recalculate. And this works very well with the Lambda architecture.
There are some criticisms of the Lambda architecture. Like, I know it's been called into question by Jay Kreps, who is one of the creators of Apache Kafka, and one of the replacements for the Lambda architecture or adjustments to it has been called the Kappa architecture. So what are the flaws of the Lambda architecture, and what are the amendments to it that people like Jay Kreps espouse?
Yeah, so I mean, one obvious, and I don't know if flaw might be too strong, but like an obvious setback or drawback is, if you don't have data that needs to be recalculated or where it's useful to look at the entire data set all at once, then if you're just trying to count, for example, if you're just counting, it doesn't hurt to just add in your new entries. You don't have to go back and look at the entire data set to figure out what the new count is when more data comes in. You just add it on. If you do have something like that, then this is perhaps a little bit overkill. And then the obvious downside is that, so that is to say, Lambda architecture, it might be it might work for everything, but there's some use cases where it's perhaps overkill. And the downside to that is now you have to maintain, streaming code and also batch code. Now, there are frameworks called, for example, Twitter has the Hummingbird project, which helps you do this, that you write, one abstraction of code and it gets turned into both real-time or both streaming and batch code. It gets implemented for you. But one of the real downsides is having to maintain and write two separate code bases. So what I think, the idea behind the Kappa architecture is that, you can ignore the batch system altogether and just have one simple system, the streaming framework, that takes care of everything for you. And I think previously this had been, a lot of people would have said this is not possible, but I think new technologies and, the fact that streaming technologies are getting better is making this more and more possible.
Yeah, and I think that's also like the use case. So if you're a company that doesn't do much analytics of like maybe 2 years ago, it may be worthwhile to go towards the pure Kappa architecture. If you can have a full streaming storage, and you can calculate things as they come in real time, but there's no need to store data that's much, much older than stuff that you would ever need to train your system on. So compared to like other systems where you do want to look at 5 or 10 years ago, you need to, at that point, batching may be something that's is easier to wrap your head around too.
I was just at a conference called QCon, and there were so many talks about all these different streaming frameworks. There was like Spark, Flink, Samza, Storm, Stylus, Heron. There were just like so many. Do you guys have a good idea for how these vary, or which ones you should choose for different circumstances? Or, I guess when you teach data engineering at Insight, maybe the idea is, like you said, more to just compare. You want to teach the engineers to be able to compare these different frameworks. I don't know. What are your thoughts on this vast multiplicity?
Yeah, that's definitely something that we always keep battling with. So at least in our point of view, we always try to keep things as simple as possible. So I would say in the streaming world, we tell the fellows that they should see it as more of what do they actually need. So with Spark streaming, for example, That's more of it works still on a batch framework, but it's doing this sort of micro batching. But with that means that you can only get down to you have a latency threshold, which is probably about half a second at best, essentially. So if you need to keep updating results in like half a second or more, then Spark Streaming could probably do the job for you. However, if you need something that's much lower in latency, for example, like if you're in an ad tech and you need to be able to provide the correct ads to a specific website within like microseconds, then Spark Streaming is going to fall behind too fast. At that point, you're going to be needing other technologies, which are more of these pure streaming. It's basically for each record that comes in, you do a computation and you just get an output immediately. So this includes like Storm. I think Flink falls in this category as well. And it's up to we want the fellows to take that into strong consideration in terms of how to pick those kind of technologies. Now, within those subsets, they would have to look more into detail of what are the benefits and the trade-offs for that.
Yeah, and I mean to I know there are new technologies, and this is always the case with data engineering, and part of that comes from our I think the data engineers are fully adopting the open source mentality, but because of that, there's new tools emerging all the time. I think if you want to just put it down to a short list, I think that Spark Streaming and Storm are kind of the go-to technologies. And with this division that Austin just described of true streaming versus micro batching, and then I personally I'm just really excited about the Flink project, which unlike Spark, which kind of operates in the batch framework and then also has this micro batching, Flink is a stream processing at its heart that can also happen to do batch processing. So I'm really excited about Flink, but it still hasn't been widely adopted so far.
Yeah, it's so funny what you guys said about the ad tech use case. Literally the last interview that I conducted, I'm not sure when this one will air. I might just air it right before this one, but was an interview with this ad tech company where he was talking about contrasting the different streaming frameworks. And he literally said early on, they leveled it down to Storm and Spark, and they're weighing the different trade-offs between the two. And they're well, ultimately we're an ad tech company and Spark has this problem of micro batching, and literally it's the same example that you just gave. Yeah. So it's pretty funny. Interesting. So, I mean, these different streaming frameworks, they define the processing aspect of data engineering, but there's also storage. What are the storage technologies and principles that data engineers need to know about?
Yeah, well, this is one of those difficult things, and I guess at a high level, there's two main use cases for storage. The first is distributed file systems, and I think the clear winner here is the Hadoop file system. Not to be confused with Hadoop's Mapreduce framework, but the half of Hadoop that is in charge of taking large files, chopping them up into chunks, and replicating those in a distributed fashion, so it is fault tolerant. I think those distributed file systems, like a normal file system, they're great for very unstructured data. You can literally put whatever you want in there. They're great for basically serving as a source of truth. That is to say, you take your most raw data and you just dump it into a place like Hadoop file system, or if you want to use Amazon's S3, I think that's another great alternative. But you just take your raw data and you dump it in there, and then you can do some further processing. The downside to file systems like that is that ultimately that flexibility and that durability comes with complexity. And so when you want to actually access the data, you're going to get it in seconds instead of milliseconds. It's relatively slow. So then the other major class of storage would be your databases, or generally speaking, data stores. It depends how you want to classify it. But distributed databases, tools, common ones that come to mind are, the ones that are based off of Google's Bigtable, which is, things like Apache Cassandra or HBase. Then you have, more like search-oriented tools like Elasticsearch, which allow you to do some pretty amazing things with both geospatial data, but also, of course, text-based data. And the main idea behind these technologies is that you give off, and I guess these all fall under the realm of NoSQL, not only SQL. You give away some of that flexibility, and you find a technology that, because of the way it indexes, is really tailored to one or two specific use cases. And so that is the difficulty, is that you now have to tailor the storage, at least for the database, to a specific use case. And maybe you might even have more than one database or more than one way that you're using your different queries require different use cases, different access patterns. And so you might need to optimize much more and kind of tailor to a specific database. And so with that said, I think most applications actually use a little bit of both the file system to store the raw data, but then you would do some aggregations or some counting, and then you'd store those aggregated results in a database for quick access for either the data scientist or end user.
Got it. Yeah, there was actually another talk at QCon that Uber gave, and I'm hoping to have the guy that gave it on the show, but he was talking about using Elasticsearch just as you described it, as kind of the storage layer in the Lambda architecture. So let's shift from talking about data engineering in terms of what it actually is to data engineering in terms of where it fits in organizationally and how big the demand for data engineers is. And so data engineering mostly occurs at bigger organizations that have scaled and they have tons of data to manage and engineer. So if I'm an employee and I'm not at one of these companies that has like a titanic data set, like a Google or a Facebook or something, how do I learn data engineering? Is there a good way to learn these skills if I'm not at a company that requires data engineers?
Yeah, so I guess, of course, there's an obvious use case for those larger companies. What we're starting to see, when we go out and talk to the industry, is that there's actually a pretty compelling use case even for medium or small companies. And I think we know many data engineers who are on companies that are under 20 people. And part of that is not just the size of the company, but the size of the amount of data you have. But anytime you have a use case for a data scientist, you also have a use case for a data engineer to help enable that data scientist to not have to do the context switching of dealing with the engineering and some of the other things. So I guess there's always kind of a use case, but coming back to your question a little bit more, how does one actually tackle and learn these things if you are at a smaller company? I think our whole philosophy and the philosophy behind Insight is that the only way you learn about these things is just by trying to develop a proof of concept project where you find, you think about what the use case is, where you actually need these tools, and then you just start exploring it and building these things. The great thing about these technologies is they're all open source, so it's relatively easy to get started, and you can just start, building out a product that actually helps your company and that uses some of these technologies. And pretty quickly you'll realize you will learn by effectively doing, as opposed to just trying to wait until a proper use case or a something comes up. There's actually a good fit for just building a project that leverages some of these ideas and concepts.
Yeah, and I would also second that in terms of if somebody doesn't want to start with, say, distributed technologies right off the bat, or say to deploy things distributed, because it's not a trivial thing. All these open source technologies they can just download onto their local computer. And in most cases, they have some sort of local mode. So they can run just on like your own Mac or your PC. And it's enough to at least get around to playing with the API, figure out how they work. Of course, you won't get the full effect in terms of how effective are they at scale. But once you are ready actually to move into that, you could use other services such as like I believe like Amazon Web Services, Azure, Google Cloud Compute. And I know I'm much more familiar with Amazon, but you could even use spot instances, which are basically like you just put a bid price, and then as long as that bid price doesn't get hit, your instance stays alive. And that will cut down the cost of instances that you want to spin up by sometimes even tenfold. So you could be looking at like a 4-node cluster. You could probably only be paying about, I don't know, maybe like 12 to $20 a month or something like that. And you actually have a live cluster there. So you could test out technologies such as Sparc and trying to write to a Cassandra cluster as well. And then you can really feel the full effects there. There's a lot of very large data sets out there that are open on Amazon S3, which you could try to read that into your cluster, try to do some computation and try to write it out somewhere else. And sure enough, you will most likely encounter some problems that you would have never even considered when it was just done on a local machine.
Okay, that's really cool. Those are some great suggestions for how to get started on our own. There's also Insight data engineering, which you guys are working on. And I'd love to get an idea for how the Insight Data Engineering Fellows program works. And I think one good way would be for David to discuss this, because David, you actually went through the program before you joined Insight as an employee. Could you briefly describe your experience at Insight and talk about what about the experience made you want to join the company?
Yeah, absolutely. Although I will caveat that Austin was also a fellow here, so you can get his experience as well. But it's a common recurring theme that we love to have people who are very familiar with our experience by getting some of our fellows that go through the program and grabbing them onto our program. So I was actually coming from a more academic background, and the Insight Data Engineering program is specifically tailored to two sorts of candidates. Those who are coming from academic backgrounds like myself and are really looking to break into the industry as a whole, and then also experienced software engineers who maybe have been doing engineering in general. We've had diverse fellows from all sorts of fields, system administration, front end, database administrators, and they're just looking to learn and get their hands on these technologies. But back to my specific experience, I came from the world of physics, and I was working in a PhD program on quantum computing, which I found absolutely fascinating, and I'm still really interested in. But is, as you've probably heard, like 5 years out, and I was told that like 10 years ago. So when I wanted to go into the industry and really work on something that's much more applied and will have a real world impact right now. And so, I had quite a bit of experience with distributed computing, but, in a really like not like a big distributed system like you see and hear about for like Hadoop, but just like, running parallel computing and using some of those, open source technologies from the 90s. And I had applied that in my, kind of simulations on my research projects, but didn't really get the experience with the tools that are actually being used in the industry right now. And so when I went through the program, basically the way it works is you build a project over the course of 4 weeks. And just as I was saying earlier, you have this, you basically build a proof of concept for a given technology or a given platform that you're trying to build. So for me, the platform that I chose was to analyze all of the U.S. patent data. So, there's going back to the 70s, there's this wide and very messy source of data. And for my project, what I chose to do was to actually clean up all this data, and then develop some sort of basic analysis so that you could actually build really cool tools that allowed you to either analyze, where innovation is coming from geographically. You can kind of slice and dice the data, or you can imagine building something like a Twitter, but for patents. So every single time someone, every single time Google posted a patent or something like that, you would get a alert. So I found this, of course, this is maybe an interesting topic for me, but what it really did was it allowed me to build, it's kind of just a tool for me to actually get to learn these technologies and build something. And what Insight did was provided me the resources and the guidance from mentors like, Nathan Mars, for example, who, the inventor of the Lambda architecture, would come in and actually, tell us exactly what that is and would guide us in our projects. And so I really enjoyed that process, and that gave me the ability to actually learn these technologies in a very focused and self-directed way. And then additionally, one thing I would say is that our program really also focuses on the diversity of our fellows. So we try to bring in people from all sorts of different backgrounds. And what that allows us to do is really learn in a collaborative way. So anytime I got stuck on something, I know that I can just, reach out to one of the people going through the program, or perhaps one of the alumni who went through the program in the past, and things that used to take me like a day of reading a book, or, I would just get stuck on for, hours. I could just talk to my neighbor, my fellow, and learn these things in, just a matter of minutes. And so that was a really valuable aspect. So, Insight is, of course, a program, but it's also a community of people that you can always go to and get help for if you get stuck on anything.
So, as you've said, Insight is this entirely self-directed, project-based learning. What's the motivation for this self-directed process rather than having classes? Like, talk about that in more detail, because that seems pretty like almost heretical, but it's really interesting to me.
Yeah. So when I first joined the program, I was actually slightly skeptical about the way the teaching was going to go, because it's all self-directed, just like you said. And so I was always the kind of person that would always just bang my head against the wall till I figured it out. And going through the program, I started realizing very quickly that wasn't going to work, and that I would have to ask my neighbor for help. And I always refer back to like the types of projects that I worked on, like my personal projects that I've done at home, in terms of like those timelines. And they would usually take like several months for me to like get those hashed out. Getting those projects ramped up just took a lot of time and making a lot of mistakes, which nobody was here to guide me, essentially. But after going through the program, I realized that I would never have been able to accomplish the project that I built in the program had I not been around the types of people that were around me at Insight. So I think like one of the biggest things is this collaborative learning style of like, we do not try to take people of just like one particular background, but having people of expertise from all various backgrounds definitely helped a lot. I was able to ask people about front end, which I had not done any front end programming before. Was able to get that through within pretty much one evening, which I think if I did it on my own would probably take me over a week. And so that really opened my eyes in terms of how beneficial Insight was, at least to me and to also other fellows too.
Yeah, I've talked to several boot camps doing interviews, and the median time for these boot camps seems to be about 13 weeks. But Insight data engineering takes only 7 weeks. Does this have to do with the project-based learning, or why is Insight like half the time of another boot camp?
Yeah, and I should even cut that down even further, because the actual time we spend on the projects is actually, let's say, the first 4 weeks, and even then it's the first part of the first week is actually choosing a project. So the amount of time someone has actually spent, doing their technical project is actually less than a month for sure. So I think we do have a very high bar for the sort of technical abilities coming into the program, and I think that's what might separate us from some other boot camps, which I think are trying to take people from maybe not 0 to 60, but very, very low bar. People who come into our program do have several years of experience programming, and I think that helps. But I really do think that the project-based approach is the way that really drives you to get something done. We kind of work on weekly sprints where at the end of each week, you have some end product. At the first week, it's producing an MVP, and then from there on, you have iterations. But basically, you are really pushing yourself, and you're pushed by this collaborative process of seeing what other people are doing to really get things accomplished in a short amount of time. And I mean, the other thing that I guess something that we really value, and a part of the reason why we don't have classes per se, is we really want people to learn how to evolve with the field. Data engineering and anything that is tied to the open source community is something that's going to evolve very, very quickly. I mean, as we saw, like when I very first started, maybe like a year and a half ago, Sparc was, a very, very nascent thing. And I mean, it's been around for a while, but it wasn't quite being used in production anywhere. And now it's very well established in just a very short amount of time. And so I think we look for people who are going to be self-motivated, who are going to be self-directed, and who are going to work on whatever is interesting to them. And we don't try to dictate now we're going to have a class on Hadoop, or now we're going to have a class on this. We want people to be able to pick up whatever tool it is and really push themselves to get something done with it in a short amount of time. Because I think that's ultimately what they need to do as a data engineer in the industry.
So throughout these conversations I've had with people from boot camps, I've been thinking a lot about higher education, and you see these 13-week or 7 or 4-week education programs versus college, which is 5-year education program. And a lot of times I come out of these interviews just feeling like, gosh, why is college the de facto thing? And I think maybe people sometimes misconstrue me as being really critical of college. But in fact, I'm more just thinking in terms of you have college, this extremely long 5-year thing, and then you have these boot camp. And by the way, many people with degrees still have trouble getting jobs. And then you have these boot camps that are 13 weeks or 4 weeks. And people consistently can get jobs out of them. Or maybe you guys would have something else to say about that. Maybe that's not necessarily true. But in any case, I feel like there is this giant unexplored gradient of education paths that people could pursue between these two polar ends of the time spectrum. So I'm curious where you guys see education going, computational education, as an increasing amount of the workforce needs to know some form of computer science or data engineering. Where are we going with this stuff?
Yeah, so from my perspective, when I went into college, I did my undergrad in electrical engineering. I've always loved physics, and that's something that I wanted to do. And related with electronics as well. But I kind of treated college as the place where I could learn how to learn, regardless of what the topic was, really. And I think that's where a lot of students will actually gain that maturity of being thrown into this big pool of with other students. You have to learn new topics. You have a lot of classes. And yes, there is value, of course, in terms of what it is that you're actually studying. But to me, what was a bigger value was every single semester picking up something new and basically starting from almost nothing. And then by the end of the semester, basically knowing a lot about it, or even before that too. And then I think that carries over even when you work into industry or even go into academia, is not being afraid of learning new things. I think everyone should have this curiosity and this kind of hunger it doesn't matter what field you're pursuing, but you should be wanting to learn more. And I think that's kind of where you can develop that, and that's in college, I think. Whereas these, and I think that translates over into a lot of these other programs, which are these much more short-term education programs, where you do need to have this type of hunger. And if you aren't curious, like it's still not going to work. These other boot camps can try to spoon feed you this material, but if you don't have this desire to learn, no one else can do it for you. So that's just my take on it.
Yeah, and I think maybe the reason why we see kind of this this dichotomy of like, you have really short programs and then you have, long academic, and for me, covering, a decade. But I think the reason why you might not see something in the middle is that there are people who come out of, high school or after working for a few years and already have that hunger and just, really want to learn these things very quickly and start using them in the real world and solving those challenges like very quickly. And I think there's other people who still want to go through that more didactic process and get that experience of really learning from the kind of one-to-many experience of being in a classroom environment. And I think there's value to both of those, and some, certain people will probably gravitate towards more than other. But I think it's really interesting to see this new development of educational models that are rethinking the traditional academic one. And I think, there is really interesting growth in that middle area. I just don't know exactly who would be the person who wants to pursue something like, a 2-year version or something like that of Insight, which I would say like the other thing about these programs is they're very intense. And so part of the reason why we limit ours to a relatively short amount of time is it would be very tricky to do one of these things for 2 years straight. I think that would be, you'd learn a lot, but you would also maybe burn out.
One of the things I think about with these 4 weeks or 7 weeks or 13 weeks things where people can learn so quickly, it makes me really question these conventional ideas we have about like brain plasticity, where we kind of say like, oh, you can only learn at such a blistering pace if you're super young. But yet I see people who are older who are going through these types of programs, and they seem to have a lot of success. What do you guys think about that, Dick? Do you think we have an underestimation of the human capacity to reformat our careers and our educations?
Yeah, and I think that is a very interesting point. And I should also say, like, our program, we've had people who come in with straight out of their undergraduate degree, and then other people who have been working in the industry for 30 years, and they both seem to learn at the same rate. I think everyone, when it comes to picking up new things and working with technologies in a very hands-on way, I think everyone can learn. I don't even think it's about age. I think it's about the amount of interaction you have with the material that you're trying to learn. I think if you're just like listening to someone else or you're just reading it in a book, it becomes very easy to. I think that's something that is not. It's the interactive nature of it that makes it much more easier to learn at any age. I don't know. That's how I feel. I really enjoy. And as I look back on my career, I think like every few years I have tried to like, quote unquote, reinvent myself or like really learn a new subject. And for me, that's been something I've always been attracted to. And I imagine I will continue to do.
It's the blessing and curse of the millennial, as they say.
So, sure.
So, I think it's interesting. Like I've seen some enrollment stats, I think, on these boot camps and the number of data scientists that are being churned out, and all I've seen is just like kind of up and to the right. Have you guys seen like an increase in the number of applications, or has it started to flatten out, or how do you see this macroscopically? Like, are the applicants still increasing, or has it leveled out?
So we still see it increasing. I think there was originally an explosion, and the story behind Insight, which was originally geared for PhDs, was that there was this problem of PhDs who could really, really smart people trying to get jobs, but couldn't. There was clearly not enough academic positions, and at the same time there was all these people looking for really smart, technically inclined people, and they found really smart people, but they didn't quite have experience with the tools. And Insight started as a way to bridge that gap. And so originally we saw that it was actually a very small number of companies that were actually open to this new position. At the time wasn't even really named a data scientist, but what we saw was, there was certainly a huge number of people who wanted to get into the field of data science. So on the supply side, there was certainly no dearth there. But on the industry side, there's kind of a relatively small number, but then as the years went by and as this new position kind of evolved and people understood that, we've seen the demand on that also increase. And so what we've seen is, pretty much sustained growth for both the people who want to get involved in the program from the fellow side, but also the companies that want to work with us and who are looking for these data scientists and data engineers. And so far we haven't seen any drop in that, and things have kept going up and to the right, as you say. I would hope that things would balance out at some point, and that would there wouldn't be a just continued imbalance, because I think generally speaking from a economic perspective, it's better if things do level out and people go into the field. But so far we haven't seen that yet, and it's pretty interesting to see if it will keep going up.
Yeah, it's also very interesting. So we've also been able to do a lot of interviews with you applicants as well. But since I joined, I've done, I think, about 2 rounds of interviews for the program. But we're definitely seeing a very common trend of the people who are applying, they're getting a much better understanding of these tools, much better than I was when I first came into this program as well. So I feel like a lot of this information of these distributed technologies and working with big data is becoming, the barrier to entry is decreasing. So it seems like it's becoming more like the more layman will be able to understand a lot of these tools without being like this overly special technology thing.
So at Insight, you guys started off with data science, and then it expanded to a data engineering track. What's next for Insight? Are there more projects in the works?
Yeah, so we actually have a third track, which we just started, which is the health data science. It's still kind of within the realms of data science, but we have a program in Boston now, which is specifically tailored for data scientists looking to make an impact in the health field, and that's a really exciting area that I think is worth keeping an eye on. So that's one aspect, and then Austin is actually pioneering another one, which we're also very excited about.
Yeah, so another thing that we're working on is we have a lot of people that have been working in industry already. A lot of them have no intention of moving into other industries. They're already working as data scientists and data engineers, but their technology stack may already be fixed. So a lot of them want to just keep improving in terms of how they do data science and also data engineering. So we've started these data labs, which are essentially these workshops to help data scientists and data engineers keep learning about new topics. So we have 2 topics right now. One of them is the data visualization data labs, which will be we're hosting in New York City and is on December 10th and 11th, which will basically teach people who want to learn more about how to visualize their data. And we've run a couple of these already in the Silicon Valley, and it's been very successful. A lot of data scientists really enjoy the program, get to work with D3, do some analysis, and figure out also how to describe that data story. And the other one that we're running on December 7th and 8th in New York City is the Sparc Workshop for those people that particularly are interested in Sparc and want to learn the basics of how Sparc infrastructure is organized. Also for people that are engineers or data scientists that may already have a Sparc stack, but just haven't really had the chance to start working with it. So what we want to do is these are just simple 2-day sessions where they get to pretty much get their hands dirty, start working with Sparc clusters or working with their data visualizations, so that when they go back to work, they can basically just hit the ground running and start working with their clusters and so on.
Yeah, and the exciting thing about both these new programs is it takes the same core idea that the best way and the quickest way to learn these topics is to just start building a tool. And both of these are, in the data labs in particular, again, they're not didactic. There's not classes per se. It's really a self-directed, project-based approach. And because these people are already familiar with the field, there's we feel like, and we have seen that it can be a very short program, and you still get a lot out of it. So we're really excited about this project-based, self-directed way of learning, and really excited to see what sort of directions we can take it and have it work very well.
Awesome. Well, David Drummond and Austin Ouyang, thanks for coming out to Software Engineering Daily. It's been fantastic talking to you. I really enjoyed it.
All right. Thank you very much.
Yeah, I think it's been great.